Here's a simple question that sounds like it came straight from a curious kid. Why do things get bigger when they get hot? You heat a metal rod, it expands. You heat a balloon, it swells. You heat the earth, well, let's not try that experiment. But seriously, what's going on? Why does heat make things expand instead of just making them hotter? To understand that, we have to dive deep into the secret life of atoms, the tiny little things that make up everything around you. Every solid, liquid, and gas you've ever seen is made of atoms. And those atoms are constantly moving, shaking, vibrating, bouncing around. Even the chair you're sitting on isn't completely still. At a microscopic level, it's doing a tiny dance whether you like it or not. When an object heats up, what really happens is that those atoms start to move faster. Imagine you and your friends standing close together at a concert, and suddenly the music gets wild. Everyone starts jumping, waving arms, bumping into each other. The crowd spreads out because everyone needs more space to move. That's basically what heat does to atoms. It gives them energy. They start bouncing around, and as they push away from each other, the whole object expands. In other words, heat equals energy, and energy equals motion. When you add heat, you're adding energy to the system, and the atoms inside can't sit still anymore. They jiggle more violently, the average distance between them increases, and voila, your metal bar just got a little longer. Now, this doesn't mean the atoms themselves grow in size. An atom doesn't suddenly gain weight and go, hey, I'm getting swole. The atoms stay the same size. It's just the space between them that changes. Think of it as a team of dancers. The dance floor didn't get bigger, but everyone started jumping and waving, so they need a little more room. That's why bridges, train tracks, and buildings all have tiny gaps called expansion joints. If engineers didn't leave those, every summer your city would sound like popcorn. Crack, pop, boom. Because the metal would expand and push everything apart. You might not see it with your eyes, but even a steel bridge can grow a few centimeters longer in hot weather. That's thermal expansion in action. Now let's get a bit geeky. The scientific explanation for this is rooted in kinetic theory, the idea that temperature is just a measure of how fast particles are moving. Higher temperature equals more motion. And as they move faster, the average space between them increases. This happens in solids, liquids, and gases. But in gases, the effect is massive because the particles are already far apart. That's why hot air balloons rise. When air inside the balloon gets heated, it expands, becomes less dense, and floats upward. So yes, that majestic science you see in the sky, it's just physics showing off. Here's a fun way to visualize it. Take a metal ball and a metal ring that the ball fits through perfectly. At room temperature, it passes through easily. Now, heat the ball, and suddenly it doesn't fit anymore. It expanded. The space between its atoms increased. Cool it down again, and it shrinks back to normal. It's like magic, except the magician is physics, and the trick is called vibration. This also explains why thermometers work. Inside old-school mercury thermometers, the liquid mercury expands when it gets warm, rising up the narrow tube. Cool it down, and it contracts. No batteries, no Wi-Fi, just plain atomic motion doing its thing. But here's the weird twist. Not everything expands when heated. Water, for example, is one of the stringest substances in the universe. Most things expand when hot and shrink when cold. But water actually expands when it freezes. That's why ice floats. The molecules in water arrange themselves into a crystal structure that takes up more space, even though they're technically cooler. So the next time your ice cubes float in your drink, remember, you're witnessing physics rebellion in action. Now, you might wonder, if atoms spread apart when heated, doesn't everything melt immediately? Good question. In solids, the atoms are bound together tightly by invisible forces, like springs. When they vibrate harder, they can move a bit farther apart, but not too much. If you keep heating, those springs eventually break,
and that's when the solid melts. Same idea for liquids turning into gases. You're just giving the particles so much energy that they escape each other's grip entirely. Thermal expansion doesn't just affect metal rods and thermometers, it affects everything. The Earth's crust expands and contracts slightly with temperature changes. Telephone wires sag more in the heat because the metal expands. Your car's tires even have higher air pressure on a hot day. That's the gas inside expanding from the warmth of the road. You, me, the coffee in your mug, we're all slaves to the same atomic dance. Speaking of coffee, ever wonder why hot coffee fills your mug right to the brim, but when it cools, it seems to shrink just a little? That's thermocontraction, the opposite of expansion. As it loses heat, the molecules slow down, get closer, and the volume decreases. So no, your mug didn't suddenly get bigger, your drink just calmed down. One of the most dramatic real-life examples of thermal expansion is in space technology. NASA engineers have to calculate exactly how much spacecraft materials will expand and contract as they move from scorching sunlight to freezing shadow. A single-degree difference can cause parts to misalign or crack. Imagine building a spaceship that literally breathes with temperature changes, expanding and shrinking as it orbits the Earth. That's not sci-fi, that's just smart engineering and physics. Here's a fun fact that might make you raise your eyebrow. Your body also expands when it's warm. Not much, but your blood vessels widen to release heat, and your body can literally puff up slightly on a hot day. Ever tried wearing tight jeans in summer and they suddenly feel tighter? That's not your imagination, it's thermal expansion working on you and your clothes. Okay, let's bring it all together. So why do hot objects expand? Because heat gives energy to atoms. Atoms move faster, need more space, and the whole object grows in size, even if just a little. It's the same principle behind a balloon expanding in the sun, a bridge stretching on a summer day, or your car's tires getting overexcited on hot asphalt. It's all about motion, energy, and the tiny invisible dance happening in every bit of matter. But here's the best part. This simple rule of heat makes things expand is one of the quiet foundations of modern life. From cooking pots to thermometers, airplanes to skyscrapers, every engineer, architect, and scientist depends on understanding it. Because when you think about it, even the smallest change in size can make the biggest difference. A few millimeters of expansion might not sound like much, but on a bridge, that could mean the difference between a smooth summer ride or a snapped beam. So next time you feel the heat, remember that everything around you and even inside you is stretching, dancing, and expanding a little bit. Not because it wants to get fat, but because physics said so. And that's why hot objects expand. A small truth about atoms that explains a big part of our universe. If you enjoyed learning this, don't forget to like, share, and subscribe to Wiseuse, where science gets explained with a little humor and a lot of curiosity.